We've seen what makes a network. Now let's talk about how networks communicate. TCP/IP, or Transmission Control Protocol, Internet Protocol, is the basic language or protocol of the Internet. It is a language that allows networks to communicate, or the glue that holds the Internet together. It is a two-layer program, the higher layer being TCP and the lower being IP. TCP manages the assembling of a message or file into smaller packets, which are transmitted over the Internet, received by a different TCP layer, and assembled back into the original message or file. IP handles the address part of each packet, ensuring the packet gets to the right destination. Packets do not travel together, nor do they necessarily take the same path, but IP ensures that the packets get to where they need to be. TCP/IP is TCP and IP working together. Together, these protocols ensure that information is sent and delivered properly. Without it, routers between hosts could not transfer data back and forth. By having a common agreed-upon standard for how network traffic will be broadcast, a web server in Germany can return a request for their homepage to a classroom in, say, Iowa. An IP address is a numerical label assigned to devices participating in a computer network that uses the Internet Protocol for communication. Each computer must have a unique IP address before it can connect to the Internet, and each IP packet must have an address before it can be sent to another computer. IP addresses contain 4 numbers, each between 0 and 255, that are often separated by periods such as the number you see on your screen. There are 2 types of IP addresses, routable and non-routable. A routable address can be reached by anyone on the Internet, whereas a non-routable IP address is not usable on the Internet, but can be used on your home or corporate network. Every machine on the Internet has its own IP address. A server has a static IP address that does not change very often. A home machine that is dialing up through a modem often has an IP address that is assigned by your Internet service provider when you dial in. That IP address is unique for your session and may be different the next time you dial in. In this way, an Internet service provider only needs one IP address for each modem it supports, rather than for every customer. Through IP addresses is how we find computers on the network. To locate a web server at CNN versus CNET, you need to know their address. This IP is their routable IP. It is known to the world. In contrast, there are IP addresses kept internally within CNN's network. That is, we do not know the office number on the door of Ted Turner's office. This is an example of a non-routable IP address. Services such as printers or file stores that are housed behind the firewall in the network for CNN would use non-routable numbers, which again are numbers that really mean nothing to the outside world. Domain Name Service, or DNS, is a naming system used for computers, services, or any resource connected to the Internet or a private computer network. It associates various information with domain names, but more importantly, it translates the domain names we are familiar with to the actual IP addresses associated with those domain names. For example, when we were talking a moment ago about needing to know the address to CNN's website, we were talking about its IP address. The likelihood of you remembering the IP address of all the websites you frequent, however, is slim. Therefore, websites use domain names, like CNN.com, which are easier for people to remember. These word names aren't useful to a computer, though, which is why when you type a domain name like CNN.com in your address bar, the computer automatically translates it to an IP address. The IP address listed on your screen translates to CNET.com. As you can imagine, it is much easier to remember CNET.com than it is to remember the long IP address associated with the page. But for a computer, CNET.com means nothing. The computer needs a code that can be used in a language it can understand, hence the IP address. DDoS, or Distributed Denial of Service Attack, occurs when a flood of requests of a server and its services are made to the point of flooding the server beyond its capacity to respond. The traffic on the network is so bottlenecked that nothing more can get on or off the network. Think of it like during rush hour traffic in LA if they shut down all of the on and off ramps. Gridlock. DDoS can be, and often is, intentional. One common method of attack involves saturating the target or victim machine with external communications requests, such that it cannot respond to legitimate traffic, or respond so slowly that it is rendered effectively unavailable. In general terms, DDoS attacks are implemented by either forcing the targeted computer to reset, consuming its resources so that it can no longer provide its intended service, or obstructing the communication media between the intended users and the victim so that they can no longer communicate adequately. Sometimes, though, DDoS is accidental. If your school district uses an online gradebook, you can imagine that at certain points in the year, such as when final grades are posted, traffic is especially heavy. It can be so heavy at times that the gradebook server may be flooded and thus unable to respond until it is reset. Ping is a computer network tool used to test whether a particular host is reachable across an IP network. It is also used to self-test the network interface card of a computer. It works by sending echo request packets to the target host and listening for echo response replies. Ping measures the round-trip time and records any packet loss. When finished, Ping gives its user a statistical summary of the echo response packets received and the time it took to receive them. Ping is particularly helpful when self-testing the network card on your own computer. When all packets sent are received, your computer is communicating well with the hosts you are trying to reach. A loss in packets, on the other hand, often signifies a problem with either your computer or the host you are trying to reach. On your screen, you see an example of Ping. You'll learn how to do this in the activity following the lecture.